Morning, everyone, and thanks for coming to the presentation. We have a full agenda for this 40 minutes, so we have to move a little bit quickly. And so at the end, we'll have hopefully some minutes for questions. I'm here, as they say, with Nikhil. He's a product manager for big data, and he's going to show us a couple of demos to show the solution. So very quickly, this is the agenda for today. First, we are going to talk about the data warehouse, the vision from kind of the original vision of the data warehouse versus the reality today. Then we're going to talk about how Hadoop can extend your existing data architecture by taking up some of the heavy workloads from the data warehouse. We're going to hear about a customer case study. And then we're going to basically show a live demonstration showcasing this approach. So back in the 90s, there was this vision of the data warehouse, the enterprise data warehouse, a single, consistent version of the truth for all the corporate data. All that sounds really, really nice. And at the core of this vision, you have ETL tools, which you could basically use these tools to take data from your multiple sources, transform it via core operations such as sort, joins, aggregations, and then load it into the data warehouse. These tools will provide a set of benefits, but primarily it will be a matter of seamless connectivity to your sources and targets. It will be a graphical interface that allows users with little or no coding experience to create the transformations, and then metadata to enable reuse and sharing throughout the organization. However, users got addicted to data, and as usually happens, early success resulted in greater demands for information. So data sources multiplied in number, data volumes grew exponentially, business demanded fresher data, business users. And if you combine that with all the new technologies, mobile devices, cloud computing, social media, all of this opened the door for even more users who demanded new ways of looking and interacting with their data. So to cope with this demand, developers were forced to push the transformations down to the database. And in many cases, they resorted back to hand coding. And the data warehouse, the reality, it became more of a spaghetti architecture, where you have transformations happening all over the place. Some of them happen on the ETL tool, some of them happen in the database, and you have coding also. So all of this happened because ETL tools couldn't cope with the demand for information. And that's how we transition from ETL to ELT, where core transformation workloads happen in the data warehouse with thousands of lines of SQL, making it very hard to develop, to maintain, and also to tune. Moreover, or the most important part of this is that these workloads are taking precious, valuable resources from your enterprise data warehouse. And this is a huge problem. Some analyst firms say that over 70% of data warehouses are performance and capacity constrained. Now, we're not saying data warehouses are bad. It's actually a very valuable and a key part of your enterprise architecture. They can do things that Hadoop cannot do. However, ELT workloads can have a devastating impact on the data warehouses. And many data warehouse administrators know that. When asking to our customers about ELT workloads, they usually will tell you that ELT consumes anywhere from 40% up to 80% of database capacity. And this gets even worse because of rarely used data that is using premium capacity on your data warehouse. So these things together make it very hard to get any value out of one of your biggest investments in your data center. And instead, you end up with a reality that is very different from the original vision. And most importantly, there's a lack of agility on the IT department because most resources, time, money, IT staff are preoccupied on keeping up with constant upgrades to support growing data volumes. And as one of our customers was saying, it's like trying to steer a heavy ship or a heavy barge with a pole. Now, when we are talking about offloading batch workloads with Hadoop, we can't forget about the mainframe. The fact is that mainframes today still play a very important role within many leading organizations. Over 70% of Fortune 500 organizations still use the mainframe. And in many cases, it's a critical data source that it also happens to go into the data warehouse and combined with other data. However, leveraging mainframe data is not easy, so it makes it a lot more fun. There are several gaps that you need to bridge, from integration gaps, like how to translate EBCDIC data to ASCII, how to understand the metadata, which is usually stored in something called COBOL copybooks. You also have expertise gaps. Like if you think about the mainframe, it appeared in the late 50s. Hadoop appeared in 2005. I mean, there's a huge expertise gap. And both of these platforms are in high demand for skills, for these types of skills. You also have security. Mainframes manage some of the most sensitive information in the enterprise. And also you have costs. If you know anything about mainframes, you know that every single operation that you perform on the mainframes will cost you CPU cycles, and that translates into money. So now, thanks to Hadoop, there's a completely new approach to solve all of these problems, and an approach that is not only scalable, but it's also economically feasible. And that's why it has become a very disruptive force within the data landscape. Now, I'm sure you have seen tons of versions of this slide from different people. And the estimates can vary a lot depending on what costs are taken into consideration and what the time frame is. But the point I want to make is, no matter how you look at it, Hadoop is always orders of magnitude cheaper. So that means not 2 times, not 5 times, but 10, sometimes even 20 times cheaper. And that's not the complete picture. The fact is that Hadoop has become this kind of operating system for big data, where other applications can run on top of it. And that's exactly what SyncSort is. We've developed unique ETL technology that is deeply integrated with Hadoop. And the way we did this is we actually made a series of contributions to the open source community. And these contributions allow us to override the sort step within the map and the reduce spaces. And these contributions, which are all committed already, not only enhance Hadoop, but also allowed us to plug in our ETL engine. So you plug it in directly into Hadoop. That way, the ETL engine runs as part of your Hadoop cluster, making it easier to ingest, to transform, and to distribute data with Hadoop. So specifically, among the benefits that this provides is a graphical user interface with a wide variety of transformations to develop complex map-reduced ETL jobs without worrying about all the intricacies, all the coding, the connectivity, etc. We provide a connectivity to Hadoop from legacy systems like mainframe and enterprise data warehouses to the newest file formats like Avro, Parquet, etc. And you can also, actually this is a great benefit, that you can also speed up existing Hadoop ETL jobs, even if you didn't develop them with our tool. That's because in many cases, sort is a core component of all these jobs. So by plugging in our sort, we override the Hadoop sort, and we can speed up overall processing and deliver faster throughput per node. So how does Hadoop fit within the architecture? Well, by shifting ELT workloads from, and the associated data from data warehouses and mainframes into Hadoop. This way, Hadoop becomes kind of this massively scalable staging area for all the data. Now, the benefits are, if if you do this with Hadoop, you can keep data as long as you want at significantly lower cost. You free up premium capacity from your data warehouse. So you don't have to, again, this is not about getting rid of your data warehouse. This is just about making better use of those resources. You can defer additional data warehouse expenditures, and you can reduce batch windows so your users get access to fresher data. And the nice thing about this is that you can even provide direct access to users for research and development, for advanced data visualization and data discovery directly into your enterprise data hub. So let me show you a real use case from a financial organization. This organization has a huge data warehouse with over 600 terabytes of data. Now, I know probably in a big data conference, 600 terabytes of data doesn't sound like much, but in the rest of the world, that is actually a lot. So this data warehouse is one of the most critical components of their architecture. They use it for core financial reporting, for regulatory compliance, and other operations like e-commerce. However, they were facing constant upgrades just to keep up with growing data volumes. So cost basically became unsustainable with marginal ROI. So in addition to this growing cost, they also had a set of unmet requirements due to capacity constraints. For example, their website handles some of the highest traffic in retail banking. And one of the key initiatives of the business was basically the ability to interact with website visitors in real time, know what they were doing, what they were looking for, and then catch them on the spot with offers tailored specifically for them. Now, obviously, they couldn't do this with their existing infrastructure. This is something that they didn't have the time, nor the budget, nor the resources to do it. So in the face of all these challenges, they made a strategic decision. They will halt any additional investments on their architecture until they figure out a better approach to meet the business requirements while also reducing the cost. So after doing some research, they look at the data warehouse, and they actually realized that 44% of the capacity in the data warehouse was due to ELT workloads, 44%. That accounted for hundreds of ELT jobs and thousands of more jobs using also mainframe data. So what they did is they stand up as Hadoop cluster, and they actually worked some time on they took a job, an ETL job, and then they started to translate that to Hadoop using Hive. So they spent 15 days translating this job. They ended up with 47 HiveQL scripts. And the good news is they actually proved this could be done. The job ran satisfactorily. They were within their SLAs, and they proved their point. However, they realized they now have another problem. How do you scale this across the entire organization? Obviously, they will need a lot of resources, an army of developers to translate all of these jobs with hundreds of jobs, about 500 jobs, to Hadoop. So this wasn't really doable. So they actually had three specific requirements. One, they were looking for a tool that will provide them with the ability to use like a graphical user interface and reuse a lot of the skills that they already had within their IT staff. Their IT staff were ETL developers who knew how to use ETL tools. The other one was a tool that allowed them to access mainframe data, because a lot of their transformations will actually end up using mainframe data. And finally, a tool that will allow them to scale or kind of to move into the future and contain costs. They didn't want to end up with massive amounts of nodes in their cluster. So our team went in and proposed SyncSort, and with the use of the graphical user interface, we were able to develop the same job in about 5 days, so 1/3 of the time. It also ran significantly faster And usually when I show this slide, the people who were involved in the test, they tell me, you shouldn't show that it's 24x faster because nobody will believe it. And of course, I'm the marketing guy. I'm like, if that's what you got, then I will show it. You may not end up with 24x all the time, but I mean, the higher throughput is evident. And again, most importantly, instead of ending up with 47 HiveQL scripts, they ended up with 4 graphical jobs. So it's a lot easier to maintain. It's a lot easier to document, to understand moving forward. So today, this application is in production. And now, not only they are saving money in deferred costs for the data warehouse, but also they are able to tackle other important initiatives that before they were just staying in the back burner. So this is a great example, but what's the best way to get started? And what we recommend is a 3-step approach. No matter what tool you use to offload, I think we have proved the value of offloading workloads into Hadoop. And this framework can help you when you tackle this type of problems. The first step is all about analyzing and understanding, documenting the workloads that you are going to offload. This usually involves a lot of SQL, because there are SQL scripts that have been created over time within the organizations. Now, what we have found is that in most cases, 20% of those workloads are the ones causing 80% of the problems. Once you have identified those, then you have to recreate those workloads or those same jobs in Hadoop, to run in Hadoop. You need the right connectivity to all your sources, data warehouses, relational sources, mainframe, operational systems, etc. And for the rewriting, of course, SyncSort is a great tool to do that without needing to write code, without the need to write code. And finally, once you've developed the jobs, then you need to deploy them within your Hadoop framework. You need the appropriate security, which is a big deal, especially if you are dealing with sensitive data. And also, you need tools to monitor and manage it. In the case of specifically of SyncSort, we provide full support for LDAP and Kerberos in terms of security. And in terms of deployment and management, we integrate with tools such as Ambari or Cloudera Manager, where you can actually monitor the jobs. You can deploy upgrades and install the software throughout your cluster using packages. So how about the first step? Well, very often, understanding and documenting SQL workloads is actually one of the toughest barriers to overcome when you are uploading ETL workloads to Hadoop. And that's why we created this very unique utility called Silk to help you analyze ELT SQL jobs. Now, what Silk does is it takes SQL, a SQL script as an input, and it will generate a very detailed flowchart of the entire job. So it even gives you hints and best practices on how to replicate those jobs in Hadoop. Now, to understand the value of this tool, let's take an example. If you take a job with 1,000 lines of SQL, this could take about 20 hours, 20 man-hours to analyze and document without Silk. The same job can be analyzed and fully documented within probably 30 minutes. Now, the process itself, it takes probably 1 minute, but then once you have the whole chart, you can drill down, you can basically review everything that it's created. And obviously, organizations don't have one script. So if you attach some figures to these numbers, I mean, the ROI is very evident. And that leads me to the first demonstration.
So what you're looking at is Silk in the web browser, and it's actually a very intuitive utility, and it saves you a lot of time, as Jorge talked about. So what you can do is on the top left you have a little button called Import. You can import your SQL. So you can basically have SQL.SQL files that has code in it, As you can see, I've imported a bunch of SQL. It was already imported into my utility here. The one I'd like to show you is a simple one to start with, and which is an actual SQL that we got from a pharmaceutical company recently, and you can see that it's got an insert statement. For those of you guys are familiar with SQL, it's insert into a temp table, and it's got a whole bunch of group by statements. In this case, it was a min function on a bunch of fields. It's about 159 fields, or columns rather, and it's doing a join with another table, and then a group by, and then it takes that and then does another insert into another table with a whole bunch of business rules. You can see that's about approximately 340 lines of code, and this thing, sometimes can be pretty hairy to understand, especially if somebody's written it and the person who's written it is not around anymore. There's no documentation, etc., etc. So you can just hit the Silk SQL chart button, as you can see here, and very quickly it generates a nice visual chart that represents what that SQL is doing. So what it does is it breaks it up into functional blocks, and we saw some joins, we saw some group bys. So what it does is it actually has data flowing up. So the flow, these green arrows are actually showing you how the data is flowing. You've got two source tables flowing into a join. That's being then grouped by, as you can see here, and then being inserted into a temp table all the way at the top here, and then that's being consumed by the second SQL statement, and the third source table, another join, and then being inserted into the final target table. So very quickly you're able to digest and parse that SQL and generate a visual representation. You can even do things like drill into one of these boxes. Let's say you want to know more detail. You can double click on that, and it'll show you what snippet of SQL this little functional block represents, and then it tells you things like what are the source tables that are being processed in this functional block, and then it tells you in sync sort technology, which is DMX for Hadoop, this will look like a join. In DMX, it's a join task. So it gives you some recommendations, gives you some best practices, and it gives you also some performance advice on how best to actually implement this when you're moving that SQL job into Hadoop. Okay, so similar thing with other boxes. You can drill down to each one of these and get more recommendations on how best to move this. One of the things that you can do also is I've got a complex SQL statement which is actually a lot more than 350 lines, and I can open that up for you here. This happens to be an Oracle PL/SQL statement, and you can see there's some hints in there. People have tried to tune it. Again, this is a real live use case. I can start scrolling down, and every time I scroll down I lose count of how many joins there are. You can start counting here. There's an inner join, there's a left join, and it keeps going, and then you start seeing nested business rules over here, and then there's another left join, a left join, etc., etc. At the very bottom there's a group by, and it keeps going, right? But a lot of complexity there. So if I chart that in Silk, it actually is a pretty big chart because of the complexity, and I can show you what it looks like here. You can see very quickly it actually gives you a visual representation, and you can actually zoom out and see what the relationships between all of the tables that are being processed, and you can see that very quickly these two tables are being joined, and then it's being joined with the other one, and so on. Whoa, sorry. And you can obviously do the same thing that we did before, which was drilling down into each one of these, right? Or you can zoom in to a certain aspect of, or a certain portion of this and get more detail. So that's basically at a nutshell what Silk does. Today it gives you a visual representation so that it's easier for you to digest and figure out what you want to move to Hadoop from your data warehouse, which is offloading we talked about. But then the next thing we're working on is to take this and actually convert it into something that you can run. So convert it into jobs that you can run. Now that conversion is never going to be 100% accurate, because there's always going to be things that are being done in SQL that doesn't have the exact translation in Hadoop, in our technology. But it'll get you at least 50-60% the way, and then you can obviously go in and tweak your jobs as required. So it saves you a lot of time and money in migration and offloading these complex SQL jobs. Okay.
Thanks, Nikhil.
Yep.
So let me switch back. And it's this one, yes. And should be quick. So all of this is really nice, but ultimately is about the getting more insights from your data. So when you look at, when we say an end-to-end approach, what does that mean? That means that then you can take that data and prepare it, process it, and deliver it ready for analytics. And what we have done, and this is just an example, but I mean, you can use Xor with any BI tool or data visualization tool that you want. But we just happen to deliver a connector specifically for Tableau, who is one of our strategic partners. And what that does is you can do all the processing, all the blending of the data, and then generate automatically a Tableau data extract file. This is what they call the TDE file. So the same way you can write to any target, like a database, you can write to a TDE file that then you can automatically open with Tableau and start visualizing your data. You don't need to install any software, any additional software, because this ships with the Tableau API. And that leads me to the other part of the presentation or the demo, because this is something that is highly visual.
All right, let me just show you something that, just to continue from where I left off. So, oops. So one of the things that we're talking about here is to actually take your data warehouse, offload some of this low-hanging fruit, which is the SQL jobs, to Hadoop. So what we're seeing here is the EDW on the left. You can take the data and the SQL and implement them, and load the data into HDFS, and then implement that SQL in a graphical job to run on MapReduce. And you're going to save a lot of resources, a lot of capacity in a data warehouse, and run it on a commodity platform like Hadoop, and do it graphically. There's no generation of code, there's no coding, etc. This entire workflow, yes?
How do you extract it?
We actually have a high-speed connector to all of the data warehouses that exist, and to the mainframe, and then we have a native connector to HDFS. So it's a graphical way of actually setting up the load from the source into the target. No, it's actually our own technology, but we do integrate with Scoop as well for the mainframe. So you could use Scoop with us, and we are actually called under the covers by Scoop.
So how is it efficient? It's a regular scoop, right? So I can just
Yeah. So let me get into the actual demo, and you'll see some of the efficiencies. So that entire workflow that you just talked about is actually going to be in one single job. So you can see here, I'm taking data from the mainframe and Teradata, loading into HDFS, and then taking that data and performing a MapReduce job graphically, and then loading the data back into the data warehouse or into Tableau. So these are the 3 steps. Back to your point, one of these things, if you actually double-click on this job, it actually is taking the data from both Teradata, in this case, Teradata, that's the database, and loading into HDFS. And it's also taking data from the mainframe and loading it into HDFS. A lot of times the mainframe can pose challenges, right? Mainframe data is an EBCDIC, it's binary, it needs to be converted. We have a very high-speed connector to the mainframe, performing that on the fly without landing the data anywhere between the mainframe and HDFS, and doing that translation on the fly, and any sort of other data transformations, and then loading to HDFS. We can also load into Avro or Parquet, as you can see here. That movement is highly optimized, and it's also very easy to set up and deploy. In other words, a lot of the mainframe data is got metadata in COBOL copybooks. I don't know if you guys are familiar. Most of you guys probably know what COBOL copybooks are, which actually we have native support for. So you can suck in a COBOL copybook, map it to your source files, and do the translation on the fly very efficiently, and load it into HDFS. Oracle too, and we actually have native OCI libraries for Oracle We don't use ODBC or JDBC, and there are ways you can actually parallelize the read from various Oracle partitions, etc. We also have the native connectors to Teradata or any other database for that matter. For example, Teradata has fast export. You can actually very easily set up your fast export and load it into HDFS. Okay.
While bringing the data from mainframe,
Mm-hmm.
you are ingesting, before ingesting, you are converting it from Exadata to whatever.
On the wire, on the fly.
So, but you are not
show
using
that.
the Hadoop memory.
No, we're using actually the data is being streamed in our buffers, so it's a pipe. So as we get data in, we actually are doing the conversion and emptying the pipe. So we don't actually need any memory as such for that. It's very minimal. So we're not storing the data in memory while we're converting. We're just converting it as it streams in. And if you actually drill into this task, you can see the bottom I have a COBOL copybook. If you're familiar with packed decimals, etc., these are the data types that exist on the mainframe. And on the source, you can have a mainframe fixed, mainframe variable, mainframe VSAM, etc. And you can set up the data to be EBCDIC. You can see treat data encoded as EBCDIC. So it's very simple to actually take mainframe data and land it to HDFS. A lot of times, folks on Hadoop have very little understanding about what mainframe complexities are, and then vice versa. So we bridge that gap. It's okay. Yes, there was a question back there. Yes. Yeah, so sequential files, variable length, fixed length, VSAM, DB2, those are the big ones, and we can pull all of those. Yeah, we can actually help you with IMS data as well. It's a little more complex than compared to DB2, straight DB2 or sequential files, but we can help you there. No, we actually are sitting on the open systems on the edge node on Hadoop, and we're pulling data from the mainframe. We don't need any software on the mainframe. That's actually something that our customers and prospects like a lot, is there's no additional piece that you need to install on the mainframe. All we're doing is pulling the data over the wire.
So you use the edge node mechanism to bring the data.
Correct.
None of your daemons are running on the data node.
No, we are running on the data nodes, and back to his question, we actually have integration with Scoop now. We just announced that, where Scoop actually does not have the ability to read mainframe data, and we contributed something to Scoop, the Scoop project, and where you can actually now use Scoop to take data from the mainframe in parallel. So let's say you have 20 mainframe files, you can use Scoop to pull those in parallel from the data nodes itself.
And we don't need, for that purpose, we don't need the sync daemon on the...
So there's the contribution deals with simple mainframe files. For that, you don't need it. But there are complexities in the mainframe world that you will actually use our engine for.
COBOL copybooks, etc.
Yeah, COBOL copybooks,
And
redefines occurs depending on...
It's not really a daemon, it's actually a runtime engine. So it doesn't
it's an
use
engine. It's not a
overhead or anything. Yeah. Can you show the Tableau?
Yeah,
just really
absolutely.
quick. Just,
so we're running out of time, but
yeah.
So back to the overall flow here. So this is the one that's loading the data HDFS. Then I'm doing a quick graphical MapReduce job. You can see there's a MapReduce link. I'm doing all of this graphically. There's no code generation or coding. And then the loading of the results, I can load it back into my data warehouse or into a TDE. So if I double click on this guy, I've got two targets. One is a Teradata, in this case Teradata, but it could be any other EDW. The second one is a Tableau file, and you can see we've got a drop down for Tableau data extract. So you can directly bypass your data warehouse and load directly into Tableau and then start visualizing that.
And as you could see in the previous screen, you also have like your mappers. You define your mappers and your reducers. You don't have to code really anything.
Yep. So that was the MapReduce piece. If I just zoom out, you can see that everything on the left is happening in your mapper, everything to the right is happening in your reducer. Mm-hmm. These are template jobs you can actually take and use in your environment. Okay. Yes. Yes. Yes, we can help you with IDMS. There's no direct native IDMS connector in the graphical user interface. You'll have to actually use some best practices to get that out. Any other questions? No? Great. Well, thanks for coming, guys.
Thank you.